planes. Hey, I need you guys to separate. That's why I separated you, so you were talking too much.
Shut up.
And again.
Hey,
boys, you need to stop as well. I'm not talking. I didn't need you to give your report there too. Okay. So you got your number plane. You've got the point 1,4. 1, 2, 3, 4, which is just there. That's our focus. And then you've got your directrix, which is the line y equals 8, which is a horizontal line that goes like that. So based on the position of the focus and where that directrix is, you can see that the parabola is going to be concave down because it goes around the focus. Remember, the parabola is halfway between fixed point of focus and fixed line of directrix. So there's our vertex, and it's going to come down like this. Alright, so when you've got your scale on your y-axis, then you can see as well what the coordinates of the vertex is going to be. Because the focus and the vertex are lined up, so we'll have the same x-coordinate. And it's halfway between 4 and 8, which is 6. So the vertex has the coordinates 1, 6. Did everyone see that? Because the focus was 1, 4. Okay, so it says find the equation of the parabola. So, because it's a concave down parabola, you know it will be in this form. Y minus k. Okay. Now you've got HK, because HK is the coordinates of the focus. Sorry, the vertex, which is 1, 6. So the only other thing you need to know is A, which is the focal length. So that's this distance between the focus and the vertex, and the distance between the vertex and the directrix. And you can see it's 2, right? A equals 2. So just substituting in the coordinates of the vertex for HK, and subbing in A equals 2 there, and then you got that. And then that's the equation of the parabola. With focus 1, 4 and directrix y equals 8.
Why does A equals 2 again?
So that's the distance between the vertex and the focus, and the distance between the vertex and the directrix. HK is the vertex. So 1, 6, that's HK. Remember back here? Vertex is HK. Okay. Does anyone have any questions about the first example? Yeah?
How do you do 1, 6?
1, 6, okay, because the vertex is halfway between the focus and the directrix. So it's 1 because it's in line, it's lined up. Same x coordinate, and then 6 is halfway between 8 and 4.
Just leave it in that form.
Yeah, you can. I think the answers in the back of the book have expand. So, all you need to do here is complete the square to change it from this form to this form. So to do that, you want to write this as x squared minus 6x equals y, and just move that 12 over to the other side as your first step. Everyone follow so far? So all we did was minus 12 from both sides of the equation. Now swap the sides.
Yep.
Yep. Now we're going to complete the square. So we're going to half it, square it, add it to both sides. So half of 6 is 3, square it is 9, and add that to both sides. Okay? Now the left-hand side of our equation is perfect square, which is the same as x minus 3 all squared. And the right-hand side is collecting like terms, y minus 3. So it's almost in this form here. The only thing we have to find is a. So we write it like this, x minus 3 all squared equals 4a y minus 3. Then it pretty much is in that form, because 4 times a quarter is just 1. So when you've got nothing here in front of the y minus 3, that means 4a must equal 1. So A equals a quarter. Because these two things are the same. What's 4 times a quarter? 1. What's 1 times y minus 3? Y minus 3. So when there's no number at the front there, it's just 1, which means A is a quarter. Yep.
Where did that y come from on the top line? Where did you pull that from?
Yeah. Yeah. Any other questions? Alright, so now when it's in this form here, you can see that the focal length is a quarter. You can also see that the vertex, and the vertex is HK, the vertex is 3, 3. And you can see that it's a concave up parabola. Okay. So to work out the focus and the directrix, you could work it out from there, but I think you should always work off the diagram. So you know it's concave up because it's x squared and there's no negative there. It's concave up parabola and there's the vertex 3, 3. So that's what you want to draw. So 3, 3 right here. Concave up parabola, and the vertex there is 3, 3. Okay, now if the focal length is a quarter, that means you've got to move up a quarter, and there's the focus. So the focus will have the same x quarter as the vertex, but the y value is just been increased by a quarter. So the new y value is going to be 3 1/4. Okay, so it's 3, 3 1/4. And I'll just write that over here. The focus is 3, 3 1/4.
I'm so lost.
Because the focal length was a quarter,
So you go up.
so you've got to go up a quarter. And then you've got to go down a quarter, and then that's where the directrix is going to be. So if we,
Because the focal length is a
so this
quarter.
is 3, and that was 3. And then we move up a quarter, 3 plus a quarter, 3 1/4. Alright, now if we move down a quarter, what's this y value here?
So what's 2 and 3/4 is what? Is that the directrix?
Yeah, here's the directrix.
So y equals 2
Exactly.
and 3/4?
Yep, exactly, well done. The directrix is y equals 2 and 3/4. Because we have to subtract a quarter from 3. So that's part A, find the vertex, focus and directrix. The vertex, focus and the directrix. Yep.
How do we find the vertex?
The vertex, so once it's in this form, HK, there's the vertex. Okay, then part B says find the minimum value of the expression. So x squared minus 6x plus 12, that's that equation there. What's the minimum value there? Where the turning point is. What's the y coordinate of the turning point?
3.
Yeah. So what's just the minimum value? It's asking for the y value.
Oh, the minimum value, like the vertex. Is that just asking what the vertex is?
It's asking for the y value of the vertex, which is 3.
What if it was concave down? What if it was concave down? Would
So
it be
or maybe it asks for the maximum value.
Oh, it would ask him
Yeah.
Why would it be 3, 3?
Because it's not asking for the coordinates of the vertex, it's asking for the minimum value
Of what?
of this, which is that parabola. Yes, Ed.
Can you explain B?
Yep. So it's asking for the minimum value of this expression. See how that expression is the same as the parabola that we just drew? So it's asking for what's the minimum value, which means what's the minimum y value, and the minimum y value is 3. Yep. Any other question? Okay, go back to your summary table and we'll have a look at the next 2 graphs there. So the next 2 can be concave right or concave left where the parabola is moved.
I didn't get it.
Okay.
Oh my
Yeah.
god.
Cameron Hoffman.
Okay, I'm going to draw these pictures again and show you how to draw them.
Yeah.
Okay, so you can put this vertex is going to be anywhere as well, but you know it's concave, right? So just draw a parabola like that. And then what's the coordinates at that point there, Sam? It's the vertex. HK. Okay, HK. Alright, now, the axis of symmetry of the parabola. Well, remember an axis of symmetry cuts it in half. So it's symmetrical. So there's our axis of symmetry. It has the same y value as that vertex, which is k, and it's got the same y value everywhere on that axis of symmetry. So the axis of symmetry is y equals k. Okay?
Oh yeah, okay.
Now the focal length is the same as well, it's a. So the focal length has been a for all of these parabolas. Now remember the focal length is the distance between the focus and the directrix. So that distance there is a, and that distance there is a. The focal length. Okay, so then you can, from there, you can work out the coordinates of the focus and the directrix, yeah?
Can the directrix be below, be below?
Yeah, the directrix can be anywhere. It can
So
be positive or negative. Yeah.
If I'm going to draw it in as a negative focus, it's much easier.
So the focus is this point here.
Yeah.
Okay, you can see what's the same about the coordinates of the focus and the coordinates of the vertex.
Oh, y.
Yeah, the y value is exactly the same. The y value is k. So you know that the y value is going to be k. And the x value, well this x value was h, and then the focal length was a, so the coordinates of the x value of the focus is going to be h plus a. Which is here, h plus a k. Okay?
Hack.
And then you can see here's the directrix. It wasn't a very straight directrix. There's our directrix. Goes down straight up. Now remember the distance between the directrix and the vertex is also a. So the same. So if that's h, I'm going to subtract a. It's going to be the same value there. So this is going to be x equals h minus a, which is there, the directrix. Because there's lots of letters in here, it makes it more confusing. But once you start putting in the coordinates, then you'll have numbers to play with. It makes it a lot easier. Stop talking. All right. Does anyone have any questions about this parabola on the left? Okay. The parabola on the right. Y squared, so you know it's left or right, and the negative there means it's concave left. So just drawing up your axes. Then drawing your parabola concave left. Very good. Okay, there's our parabola concave left. What's the coordinates of the vertex, Sam?
HK.
Well done. Nice, HK. Sam, what's the focal length? Oh, sorry, no, Sam. Ed, you just answer the question.
Focal length.
Yep. Same for all of them? A, yes.
Yeah.
A, focal length is always A. Okay, so our focus, we'll say it's there. Means our directrix is there. Yeah. And our axis of symmetry will go through the middle of the parabola. And it will also go through focus and the directrix. So there's our axis of symmetry. Our axis of symmetry has the same y value as the vertex, which is k. So it's got the equation y equals k. So that's our axis of symmetry. Okay, now go back to the focus here. What's that distance there? Yep. What's this distance here? A. Focal length. Now this coordinate here is H, because that was K. That's the vertex there. What will the focus be? Yep, exactly. H minus A. And then K, exactly. H minus A is the x coordinate, and K is the y coordinate. Then our focus. And then our directrix is here. A to the right. Exactly, it's H plus A. Because it's an equation, x equals, because all the x values is always H plus A. There's our directrix there.
Yep.
Okay, does anyone have any questions? Does that make sense? Cool.
Kind of.
Gonna change slides? Okay, 2 more examples and then that's it. So I'll give you a chance to write down these examples. I'll just pause it. So always working from a diagram. So we've got our focus and our vertex here. Okay, so plotting these 2 points. Once you've plotted these 2 points, the vertex and the focus, you'll be able to see which way it curves, which way its concavity is. So 1, 3. 1, 3. That's the vertex. 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. 9, 3 is the focus. Okay. So based on where the vertex is and the focus is, which way does it go?
Goes to the right.
Yeah, okay, right. You see that, Jason?
Yeah.
Yeah. So, oh, cool one. Concave right, because they told you that was the vertex. And there's the focus, so it must go concave right. Alright, now because you've got the vertex and the focus there, you can see clearly what that distance there is. Yep, that's the focal length, and it equals 8. Can anyone not see that or have any questions about focal length?
It's just the main focus and
Yep. Okay, so because it's concave right, you know it's one of the y squared parabolas, which is one of those ones. And it'll be this one, positive. Sorry, it should be k here. X always goes with h. So x minus h and y minus k. Okay, so that's the general equation that you're going to use. So now you can just substitute in. You've got hk, that's the vertex, and you've got a, which is the focal length.
So we're trying to find.
The equation of the parabola. Yeah, so it'll be y minus 3 squared equals 4 times 8.
32.
Yeah. X minus 1. 1, 3 was the coordinates of the vertex.
We just do it like that.
Just leave it like that, that's fine.
Is K the Y?
Yeah, because it's always hk. So h is x coordinate, y is the
that's
y
I reckon
coordinate.
H should be height. Like it's in Y.
You can use that a
So
letter for
H-
AB. HK. Like we did, you know, when we did the circle one? And then the circle's HK.
Oh,
We've been using HK a bit this year.
I do AB, so.
Alright, last example, I'll give you a chance to write it down.
Go to compass.
So, we're going to do exactly what we did before. So, to find the equation of a parabola, it's got to be in this special form like this. And to get it in that form, if it's not, you always have to do the same thing, which is complete the square. Whatever the square term is, we've got y squared here. That means we want to move, we'll keep the 4y there, we'll move everything up to the other side of the equation. Alright, and then we'll be completing the square root form. So we've got y squared plus 4y. There you go, equals, move the 24x over, and move the 4 over. Yeah? Any questions so far? Alright, then you gotta do
Half of the square and move to the side.
at to both sides. Yup.
Side, yep.
Half it, square it, add it to both sides. So half full,
2.
square it, full, add it to both sides.
So it's
So-
y plus 2 all square
Yup, y plus 2 all squared
equals 24.
equals, yup, 24x. Now, pretty much got it in this special form, but it's not very clear to see from there what the focal length is and what the h part is.
H is 1 or something, isn't it? Minus 1.
H is 0.
H is 0, yeah. So we've got this 4, A, yeah. And then we've got x. Oh, x minus, so because it's a formula, it's minus, same thing. Okay, but now you can see 8, oh, not 8, 6.
Oh,
It's okay,
Oh
no,
my.
no big deal. 6 times 4 is 24. 24x, and then you got the minus 0 there because now you can see clearly what the vertex is, HK.
Wait, why is it 0 and where's 0?
Because if you put another number there, it would change it. So when you expand these, x minus 0 is just x. Times 24 is 24.
Good one, Isaac.
Alright, so what does it say? Find the coordinates of the vertex, the focus, and the directrix. So the vertex, remember, is HK. So it'll be 0, negative 2. Why is it negative 2 and not positive 2?
because it's
Because you got fractions.
Plus, yeah, and the normally the formula is minus. It's negative, negative ones. Yep. Okay, so this is vertex. Alright, is this concave up, down, left, or right?
Right.
We're both.
Right.
What's the focus?
Yep.
What?
Because it's y squared, it's left or right. Because it's positive here, it's right.
Oh yeah.
So you go concave right.
Wait, there's one?
Yeah.
in the vertex.
Yeah, and the vertex is
Oh,
0,
one
negative
axis.
2. So on the axis there, and that's negative 2, so it means that that will be the x-axis there then.
You have to draw it.
Yeah.
Wait, what? Which one's this?
So there's the vertex at 0, negative 2. Okay. What's the focal length?
6.
6. Yep, there's the focal length. So we're going to move up 6. Here. So the x value then will be 6. And the y value will be the same. Yeah. So there's our focus. So see how I'm working off the diagram to find this out? I'm not using those formulas that we wrote down on that summary sheet, like going h plus a, h minus a, and all that. Just work off the diagram. I think working off the diagram is the best way to work out these questions. Alright, so there's our focus. So remember our focal length was 6.
Yep.
So, put our 6 back the other way.
Negative 6.
Exactly. But what equals negative 6? Yup. There's our directrix there. At x equals negative 6. Make sure you've got a letter in front of that, because sometimes the directrix is y equals.
Wait, wouldn't it be? Oh, right, okay.
So the question said find the coordinates of vertex, focus, and the equation directrix. So that's parabola.
That's it.
So that's it.
We did it.
So what are you going to do for each of the questions in today's exercise?
Diagram.
Yeah, totally. Work up a diagram.